All right, let's begin with some announcements. I hope it's not confusing, always changing back and forth between here and the computer lab, but when we don't need to be in the computer lab, I like to make it available for the many students who are always trying to use those facilities. Plus, I think it's a little bit easier to concentrate in here when you don't have a monitor obstructing some of your view. So we'll be back in the computer lab just because we've got some Excel things that we're going to work on Sunday. Homework 12 will be due on Tuesday of next week. We've already sort of begun some of the topics that are included on that assignment. And then a week from today, you'll have the third and final quiz of the semester. So you can begin preparing for those things. The coverage of the quiz is just what we've had since the last assessment. I don't remember if that was the exam or the previous quiz, but I suppose we could look at the course schedule. Was the exam? All right, so just the material since the last exam. Today we're going to be continuing to talk about break-even. And in class last time, we talked about the kind of break-even where you're comparing two alternatives. All right, so here's a graph showing the number of items, either the number of items that you're making with a certain piece of equipment, that would be the most common thing, and then here is cost on the vertical axis. And what we were trying to find out is what is the number of items that you have to make before one alternative is cheaper than the other alternative. And what you'll notice is that most of the time when you're comparing alternatives, there will be differences between them. One will maybe cost more initially, and maybe one of them will have higher operating costs. Now, if the one that's the most expensive to initially purchase and it has the highest operating costs, then your analysis becomes very easy to reject that alternative, right? Because if it's just always more expensive, then and then it generates identical items, then you don't need the more expensive one. But here is the case where I'm going to label them option A and option B. And just to summarize from last time, option A is the alternative that has a higher initial cost than alternative B. And so how it justifies that higher initial cost is the slope is flatter. What does it mean that it has a flat slope compared to alternative B? All right. So something about the number of items that we make, it's the more you make, the costs are increasing lower. That means that the variable costs are lower for alternative A. So something about the use of that alternative is more efficient. It's using less material, or its operational costs are lower. Maybe it requires fewer operators. You know, somehow the process is automated. So it may be more expensive to set up the robots than to have somebody doing it by hand, but then once the robot is operational, it's less expensive than the person. So this is what we did last time, is we found where is that point at which one alternative is less costly than the other. And since these are costs, you're actually looking for the lower of the two. You're not trying to maximize costs, you're trying to minimize costs. So today we changed things a little bit. And let me dim the light so you can see this picture better. Anybody know what you're looking at in this photo? You're looking at Best Buy, right? It's an electronics store in the United States. So let's analyze this image a little bit more deeply. So is it day or night? It's night. Actually, it's very, very early in the morning. And this is a Friday morning. There's a holiday in the U.S. called Thanksgiving, right? Thanksgiving is always held on a Thursday. It's like sort of a harvest feast. And then the day after Thanksgiving is an unofficial holiday. And people have started calling it Black Friday because it's when people go to the shops very early while it's still dark out. The reason why people are lining up, you'll notice that people here, they're sitting down. They've been there so long that they had to take their own chair so that they could be sitting in line waiting. And you also notice that these people are wearing coats. It's cold outside. People will line up and wait all night long in the cold when they should be sleeping. They have a stomach full of turkey and potatoes, and so it's probably they're very drowsy, but they're standing in line. So why? Why are they standing in line when the moon is out and they should be sleeping? It's because the prices are so low. This is a representation of demand. When you've got people lining up to buy your products, it's because there's demand. Sometimes people line up for Apple products, right? It's not because Apple products are cheap. So there's different ways to stimulate demand. Sometimes you're selling a product that's so unique and revolutionary that people will buy it even when the price is high. But more commonly, you don't have that control over people buying your product. Most people aren't selling something revolutionary. Most people are selling things that have substitutes and alternatives and are just sort of commodities. So let's look at an ad here. Here is why people will line up on Black Friday. This is a Black Friday ad. And so, for instance, a TV. Maybe some of the highest quality TVs are a little bit unique from their competitors, but most people are buying a TV where it doesn't matter so much if you buy a Mitsubishi TV or Samsung or some other brand. What will get people lining up is the prices, and so these prices are very low. So what's driving this demand is the low prices, and I guess the people who are standing in line all night, maybe they don't value their time as much as people who aren't standing in line, because if you're standing in line for 10 hours to save $10 on a tablet, then you've said that your time is only worth $1 per hour, right? But I guess for some people it's just the thrill of the hunt. You know, in ancient times we used to hunt for our food. Now we don't hunt for our food, now we hunt for our bargains. So it's a substitute, I guess. So what we're talking about today is how you can stimulate demand based on the price of items. Now, price is what you have control over as a seller. You know, if you're offering something to the market, you can't directly dictate how many items are being sold. You can only offer an item to the market and set the price of your item. Now, if other people are selling an identical item or something that's a good substitute for what you're trying to sell and they're charging less, you probably won't sell as many things. So demand is a dependent variable. It depends on not only the price, but then also the quality of your item, the conditions of the market. But we're going to simplify this relationship and just say that price and demand are related, and those are the two variables that we're going to look at. So fill in the blanks here. If price increases, demand will decrease. Right. And so we see that sometimes in the fuel markets, that when petrol becomes more expensive, people will try and consolidate trips. They'll start doing things like carpooling or taking public transportation more often, or maybe if they were going to take a long trip, they'll take a shorter trip to burn less fuel. If price decreases, demand will increase. So people consume more when the cost is cheap. All right. So here's the relationship that's showing that. On the horizontal axis is demand, so it's how many items you can expect to sell, and on the vertical axis is price. So consider the blue line. It's saying that if your price is high, then your demand is going to be low, but if the price is low, demand will be high. Now it's a little bit strange here that we have put the independent variable. If we go back to what we were saying, the independent variable is what we control. And more typically, when we're graphing things, we will make graphs where the independent variable is on the horizontal axis. But let's not let that confuse us. I mean, the independent variable can go on either axis. But here, the formula, P equals A minus BD. So these variables, P obviously is the price. It's the selling price per unit of whatever it is you're selling. D is the demand, so it's the number of units. But let's look at these other things. if you have the intercept there, where zero demand, there's going to be some price associated with zero demand. So think of it this way. If you had a store or a business and you set a price that was so high that nobody bought it, that is what the intercept is. And so that intercept, A, is the price where there's zero demand. And as soon as you lower the price to just a little bit less than A, then finally you're going to see your first little bit of demand. Another thing you're going to notice is that this is, just to simplify things, a linear relationship. In the real world, price and demand aren't necessarily linear. But for today, for our first look at these principles, we're going to assume that lowercase b here is the relationship between, you know, if you leave, you can't come back, right? All right. Lowercase b is that the unit increase in price leads to a certain decrease, the demand increases when the unit price decreases. So that lowercase b is just the slope of this line. All right. So we have price as a function of demand here. There's a relationship between them. Really what you do, though, is you choose a selling price for your item, and then the demand will follow based on that price. But with these formulas, D is the demand, P is the price, revenue, how much money you're getting, depends on the price that you charge for your item and then how many items are being sold. So it's the product of P and D. Those two things multiplied together. We, on the previous slide, had this formula that was, you know, the graph of the relationship between price and demand, so it was A minus BD. Let's substitute P into this formula for revenue, and what we get, the total revenue, the money coming in, is A, which is the intercept, where there was, it's the price at which there's no demand, times D minus B. B was the slope, multiplied by D squared. So let's look at the graph of this function. All right, it's a parabola. So why is our revenue low on the left side of the graph? No one is buying because the price is too high. So you don't have very much revenue over here. Why is the revenue low on the right side? Okay, you're selling a lot of items, but the way that you got to selling a lot of items is you lowered the price so much that now you're not making very much revenue. So you can have low revenue because you have low sales, or you can have low revenue because you have low prices. All right? So sometimes I try and point out commonly made mistakes so that you can avoid the mistakes. One of the mistakes that I see students making again and again is saying that this is the best amount of items to sell. Here, D hat, there's going to be several different D's today. There's D prime, D star. This is called D hat because it has the little, it looks like a hat. Okay? So D hat is the demand that's associated with maximum revenue. And I just said that that's not the best place to be for a business. Why? Why isn't that you don't want maximum revenue? What have I, several times during the semester, I've said that if we look just at the economics, what's the objective of a business? Maximize profit. Good. This is showing maximum revenue. Revenue and profit aren't the same thing. They're related, but revenue and profit aren't the same thing. So write a little note to yourself in the margins. Maximum profit is great. Maximum revenue is great, but maximum profit is really what you're after. And it's not common for those two things to be the same level of demand. So here, D hat is merely, it's the demand that maximizes your revenue. But what is profit? If we're going to write a formula for profit, and it only has two components, what's the formula for profit? All right, it's revenue minus expenses, and let's call those costs. Last time in class, we said cost has two components. I heard fixed cost, and variable cost. Just for a reminder, what type of expenses fall into the category of fixed? Rent. Right, and what's the definition of fixed costs? It's the thing where it's the same month to month whether you make and sell a few items or make and sell a lot of items. That's why we call it fixed, is it's the costs that are unaffected by your level of productivity. Whereas variable costs, what's an example of a variable cost? Labor costs. Okay, labor costs can be variable. Materials, absolutely. Right, and so variable costs are those expenses that are affected by your level of productivity. Okay, so let's move on to the next slide. We've seen this parabola. It's showing us the revenue as a function of demand, and our reminder that total costs are fixed and variable. Now, by the way, variable costs, this is a capital C sub V. Variable costs are the unit variable costs, so now this is a lowercase c sub v times d, which is the number of items that you're selling. And so let's take the Twinkies example. If you use 1 cent of sugar in each Twinkie, and you're selling 10,000 Twinkies per month, then you could find your overall variable costs by multiplying those two together. 1 cent per Twinkie times 10,000 Twinkies, right? So the total variable costs is the variable costs per unit multiplied by the number of units being produced. Now here's what you want to do. When you're operating a business, your objective isn't to maximize revenue, it's to maximize profits. And sometimes the strategy of the company is to maximize revenue at first. For instance, technology companies are very renowned. They're notorious for losing money for lots of years, like Amazon, Google. For a lot of years, those companies didn't make a profit. They were just trying to capture market share. They were trying to build a big base of users, and then they can try and become profitable after a few years when they have lots of customers. But in the long term, you need to be profitable, and so to maximize your profit, you should sell the perfect number of items. Okay, so D hat was maximum revenue. Optimal demand, D star, is maximum profit. What do you think is maximum profit? Well, you've got a formula for it, but what is it? All right. So if we look at this formula, you want to have big revenue and low costs, right? And so just conceptually, here was a revenue curve. What do cost curves look like so far? What have we had? You know, it started over here, which was our fixed costs, and then it just goes sideways from there. You know, a linear trend for our costs, we're assuming. All right, so this is our revenue, and this is our cost. So, you know, as far as the equation goes, here's how you find optimal demand. But let's just look at it graphically first. What is profit? Profit is revenue minus cost. And so it's the distance between these two lines, right? Because this is money, this is amount, and here along the horizontal axis is D. So we want the revenue line to be way above the cost line. So we want to maximize the distance between these two. Is this the maximum distance between revenue and cost? Where should I move, to the left or to the right? Okay, I want this to be bigger and bigger and bigger. So I just try and find where is the point where I've got the longest distance between revenue and cost. And that tells me maximum profit. So that's what this formula does, is it's comparing the slope of two lines. A is the slope of the, if we go back to this, it's the intercept of our function that relates price and demand. So A is, I'm sorry, no, it's not the slope. A is the intercept of the demand. It's the price at which there's no demand. All right, so back to the formula here. The price at which there's no demand, and then this is the variable cost per unit divided by 2B, where B is the slope. All right, so you'll notice that here on the figure, see you next time. Thanks for stopping by. All right, so here are the 2 points that we're going to call break-even points. This is where, to the left of it, you're losing money, right? So to the left of this point, your revenue is below the costs. And that's a bad place to be if you're operating a business, because it means you're losing money. So why are you losing money on the left? At this first break, to the left of this first break-even point, if you're going to explain why you're losing money. Okay, cost is greater than revenue. But why is cost greater than revenue on this left side? Like, diagnose it. What is it? The revenue is not satisfying the cost? That's like the definition of unprofitable. But like, explain why you're unprofitable. Like, tell the person who's a business owner, what are you doing wrong? The price is, what you're trying to do is you're trying to charge people too much. And so the demand is low. And since the demand is low, you can't cover the fixed costs. Like, because the variable costs per unit are the same. But down here on the left side, the problem is, if you're going to explain to the business owner what's the problem is, you're not selling enough of the things to cover your fixed cost. You can't cover your fixed cost. And so this break-even point, what you're doing here is now you're finally covering your fixed costs and your variable costs for however many items you've made at that point. Now, if you sell too many, you can become unprofitable again. And that's so counterintuitive. Like, most people would, at first glance, think the more you sell, you're better off, right? But what is the problem from selling too many items? It's how you stimulated that demand, is you lowered your prices so much that now it's too cheap. And so your revenue is declining because the prices are declining. All right. So we've got formulas that will help us to find D hat, which is maximizing revenue, D star, which is maximizing profit, and then D prime, which is those threshold points. In between them, we are in the profitable range. To the left of it, of the first break-even point, we're unprofitable. And to the right of the second break-even point, we are unprofitable. Okay, so here is a conceptual graph of those points. And this is something that you should be able to recreate from memory and label the points. So I don't necessarily consider that just memorize it, but understand it well enough, and you can explain, what is this point? What is that point? I like short answer problems on exams because it helps me to understand how deep you understand a subject. And so I think that you should be prepared to explain each one of these variables and explain the chart in general, like what it's illustrating and what the trends are. Yep, these are the break-even points, D prime 1 and D prime 2. So you want to be operating inside of this range, at least, and hopefully in D star. Now in the real world, what's hard is that you don't exactly know this relationship. A real company doesn't have a perfect understanding of how its price is going to affect demand. They can do market studies, though, and try and estimate that relationship. But for today, we are going to just play around with some numbers so we can get a feel for how things work. So I've given you the in-class exercise for today. And I've described a company that is producing an electronic timing switch We have fixed costs of $73,000 per month, so that's including their salaried employees, that's including their rent and the insurance, all those fixed costs. And then the variable cost is $83 per unit. So that's including the labor cost per unit, the materials per unit, and so on. Here's the relationship that they have that expresses the difference between price and demand. So if they set a price of 180, how many units are they going to sell? If they try to charge $180 per item, then their demand will be 0. But if they charge less than $180 per item, then they'll start to see a positive demand. All right. So I'd like you to work through these 4 steps, A, B, C, and D, and I'll be circulating around with the solution as you do it. All right, so here's the key. As I was walking around, it seemed like everyone was successful in identifying A is that intercept, B is the decrease in the price for increasing demand. The fixed costs were $73,000 a month, the variable cost per unit 83. So it's 2425 units for the optimal demand. And if you go through the process of calculating the max profit, it's 44,612, and then here's our break-even points. And so you'll notice I did a little sketch, very little, sketch down here. And so I've sketched our break-even points. Here is D star, which is maximum profit, cost curve, revenue curve. In the homework, I asked you to do this on Excel. So let's think about how you would use Excel to put together a graph for this one. We're going to have one column that is our demand. So this is the number of units we're trying to sell, and then we're going to have one column that's the price that's associated with that demand. And so let's say if we have 100 units, 500 units, 1,000 units, and so on. Okay, the price function is 180 minus 0.02 times the demand. So this is the price for whatever number of units I'm selling. The next thing we want to have is revenue. So revenue is just going to be the demand times the price. And I guess I could format this as dollars, since that's how this is, currency. All right. What about cost? Costs is going to be the fixed cost, which in our example that we just had, let me add a couple of lines up here at the top. Okay, so fixed cost is, this one was 73,000. And by the way, all of these amounts were per month. And then the variable cost, C sub V, variable cost per unit, is 83. Those are also currencies. All right, so cost is going to be the fixed cost plus the demand, the number of items we're selling, multiplied by the variable cost per unit. And the reason why we have this instead of just putting it into the equation is that then if circumstances change and your costs go up or go down, you can see how that affects your curve. So revenue, costs, what about profit? It's just the revenues minus the cost. And so now we can see that we're not yet broken even. What did we say was our break-even point from the formula? 932. So let's see, 930, 935. Let's see if it goes from loss to profit in between those two. It does. Here was the loss, here's the profit. What about 931? Oh, 931 is a loss, 932 is a profit. All right. So then if we wanted to make a curve that shows that whole thing that we just saw, we need to have we'll do it in increments of 500 just to see how that turns out. It may not be enough points for a smooth graph, but we'll give it a shot. All right, so now we want to insert on the handout for the homework, I think I say to use a scatter plot, which is here, scatter, and we are going to not show the points, and we are going to smooth the lines in between the points. So here, let's add some data. We'll have on the x-axis is supposed to be our demand. So here on the x-axis is demand. On the y-axis, if I want to have, for instance, the profit. So there is that parabolic curve, and maybe I want to add, wrong way. I want to add another series, which is, this is going to be my costs. So the demand on the x-axis, and then here is the costs. All right, and then we'll add one more that is the revenue. So demand versus revenue. All right. Now, did I do the wrong thing? All right, so here's this. Let's add demand versus revenue. Okay, and then we also want to have demand versus cost. Isn't that what I did before? Okay, yeah, that looks good. All right, so here's the break-even points. What you'll notice is that this break-even point is when the profit first comes above zero. That's what we define as break-even, is the first time you see profits. And then here, where these two curves intersect each other again, is with the last point at which we see profit. So here's a curve. We would want to, of course, add labels to this. So we could have axis titles here. We would say this is demand, and then this is, amount, money amount. And then probably what I ought to have done as well is have a legend, and then change these so that they're not just called series, but I should change them so that it is, let's see, design, select data. Yeah, so series 1 is profit. I can just call it profit, and then that will show up on the trend there. Edit series 2 is what? The revenue. And then series 3 I will call the cost. All right, so now this is the sort of chart that I would like for you to include on the homework. And it's easy to make. We just showed how to do that. We are out of time for today. Remember that what you can do is get started on your homework assignment. Who could resist, right? That'll be due on Tuesday. Hope you have a nice weekend, and I'll see you on Sunday with your returned projects.